With this video, I'm going to demonstrate how to use Excel to answer some finance problems. Now, if you have Microsoft Office on your computer, you should have Excel. If you don't, you still should have access to it. If you look in the top left of My Path or Outlook, you should see the web browser Outlook, that is. You should see these 9 dots. If you click on that, you should see this Excel app. It should allow you to open it up of a workbook, notebook, spreadsheet, whatever it may be. So you can actually work in Excel. And it looks something like this over here. So let's look at some problems. So on this one, we want to find the amount of money in an account. This is for a one-time investment. Now, Excel doesn't have an actual function for a one-time investment that's compounded in this case, but there you can modify one that does exist. So I'm going to type in, I'm clicking on the cell. I'm clicking equals FV, which is for future value because that's what we're trying to find, a future value. Now this is actually for, double click it by the way, this is actually for multiple deposits over a certain time period. Like every month there's a deposit. This is a little different. For this problem is a little different. This is just a one-time investment. So but you can still use this. You just have to modify it a little bit. So with the rate, I'm going to type it in like I will every problem. So I'm typing 3.9%. Make sure you use the percent symbol. Divided by monthly is 12, comma, and then NPER is the number of periods in a year, compounding periods in a year. So that's 12 times 4 monthly for 4 years. So that's 12 times 4, or you can just type in 48, but Excel will do this for you. Now payment, this isn't a payment. So what I'm going to do is I'm going to skip it. And then I'm going to type in the $100 that's invested. And then just hit enter. And look at there. See the answer, 116.85. So once again, when it's a one-time deposit, I'm skipping the PV and I'm doing comma, comma. Now for this example, we're actually looking for, it's a one-time deposit that we have to find. So we have 10,000 at the end of 10 years and it's compounded quarterly. So this one's a future value. So I'm typing, well, make sure you type in a new cell. So I'm typing equals a future or a present value this time. The first one, I did use the future value. This one, I'm going to try to find the present value because it's what I need to invest right now. So I'm going to do equals PV. And you'll see the same information. So I look for the interest rate, 4.1%. Quarterly, so it means divided by 4 because quarterly is 4 quarters in a dollar, comma, and then quarterly is 4, 10 years, that's 40. So this time I'm just typing for the 40. The payment, it's not a recurring payment, so I'm going to skip that, and I'm going to type in the 10,000 now, and just hit enter, and you'll see the one-time deposit. I'm not sure why that's doing that. I changed the numbers in there, so just totally disregard that. I think I'm going to fix it right quickly because it's bothering me just a little bit. Okay, so that one, what I typed in, I use a PV this time for present value, and once again, since it's a one-time deposit I'm looking for, I do a double comma and then the 10,000 at the end, because those formulas don't actually work for the way they're supposed to, where they're actually designed for a one-time compound or for a one-time deposit. However, this one is a big deal. This one is a loan problem, a loan formula, or a loan problem that we're asked to find the monthly payments for $100,000, 30 years, 6% interest rate, compounded monthly. So this one, I'm going to use a PMT formula because I'm looking for the exact payment. So I just type in PM, double click the PMT. This one does account for monthly payments. So this one's actually really easy, to be honest about it. So let's do the rate, 6%, monthly divided by 12, comma, 12 times 30, because that's NPER. That's number of compounding periods, number of payments. And then this time, since this is monthly payments, I just need to type in the 100,000 as it is. That's the present value. That's how much. That's the money you have in your hand when you take out a loan. I just hit enter, and look at that. That's easy, by the way. Definitely take advantage of that. Now this next problem, next two problems are annuities. Annuities are money that you deposit into like a interest earning account, a retirement account, and they are regular deposits. So you have to be a little bit aware of this. So this one, find the amount of money at the end of after 18 years, and it's compounded monthly. That is a future value problem. So I'll do the equals FV again. The rate, same old, 2.1% divided by 12, and it's 12 times 18 for the number of compound periods, or the number of deposits, what it really is. And then the present value, this time I don't do a double comment because this is $50 each month. The first example I did was a one-time deposit. This one is $50 each month, so I just go ahead and type in the 50 and just hit enter, and it gives us the answer. So that's the way the FV formula was designed. It's designed for regular deposits. So the one I did the first example for this one, it was for a one-time deposit. That's why I did the comma. This one is for regular deposits. So that's how this feature is designed. Now for this example, we have an annuity problem once again, because we're making deposits, regular deposits. In fact, they're each quarter. So we have 100,000. So we want to know what we deposit each quarter. That's why it's an annuity. We're earning money this time. So the deposit is the same thing as a payment. So let's do equals PMT, because you are like to get a payment into your interest earning account. The rate is still typed in. You still type in the same way, 3%. Divided by quarterly is 4, so we do 4. And then 25 years for 4 quarters a year, that's 100, or 4 times 25. The present value is something we don't know because that's going to be the regular deposit, so we're going to skip that, use a comma. And future value is 100,000. Is what we want in the final. After 25 years, make sure it's 100,000, and just hit enter, and you'll see the 675.02. So Excel does have quite a few features. Highly recommend using these, or using these features using Excel. If you don't have a graphing calculator, that is. And so take advantage of it. Hope you have a great day.